Hello everyone, my name is Oscar. I'm the teacher of Information and Communication Technology in Senior 6 classes. My channel helps the viewers to increase their knowledge and skills in Information and Communication Technology. So, unit number 1 is database design. We will have different lessons, for example, database relational model. Let's go right now. The lesson number 2 is database relational model. We are going to see what is it and some examples of database relational models which are used in a relational database management system. So what is a relational model? A relational model represents the database as a collection of relations. So a relation is like a table. Each relation or table has rows and columns, where intersection of a row and a column is called a cell. So, in other words, a table is like a set of rows or records. So, each table has rows and columns. The rows are also called records, while the columns are also called attributes or fields. So RDBMS means Relational Database Management System. This is like a package where there are some software which can be used to create relational databases. So we have various examples like Oracle, DB2, SQL or structured query language server. We have MySQL, we have Access, and so on. These are the software which are used to create relational databases. So we have some terminologies which are used in the study of relational model, or simply we call them relational model concept in a database management system. So what is an attribute? As I have told you, an attribute is like a column. Each table must have the columns, must have a finite number of columns or a finite number of attributes, or simply a finite number of fields. So attribute is like a column or a field. We can say that it's like the set of vertical cells, where each cell contains a value for that attribute. So what is a table? A table is a database object which is used to store elements in a format of rows and columns. So a table is a database object used to store data organized into rows and columns. Tuple. Remember that a relation is a set of tuples, or just is a set of records. So a tuple refers to a single row or a record. Relation schema. So Each relation must have its corresponding structure because it is not necessary that all relations have the same number of attributes. So, relation schema refers to the design and structure of relation, including relation or table name, attribute name, and so on. What is a degree in a database management system? As a table consists of a number of attributes, a finite number of attributes, the total number of attributes or the total number of columns is called the degree of a relation. A degree of a relation or a degree of table is equal to the number of its attributes or columns. We have what we call cardinality. Remember that during the study of set theories, we saw that each set has a given number of elements. So, cardinal of a set means the number of all its elements. So, as I have told you, a table is a set of tuples. So, the number of tuples or the number of a row or the number of rows of a given table is called cardinality. We have a column which is same as an attribute. So a column represents a set of values for a specific attribute. Or as I have told you, a column is like the set of vertical cells or set of vertical values or tuples of an attribute. Relation instance is like a relation. So, relation instance is a finite set of tuples or finite set of rows which forms also a table or a relation in a relational database management system. Attribute domain or simply a domain, as I have told you, each table has a finite number of attributes and the attributes will be given the values. So the values to be given to attributes will be different depending on their data type or the kind of value to be stored. So domain refers to the set of allowed values an attribute can take. So this figure shows an example of a table or a relation. For example, we have our relation is called the relation. There is no specific name to this relation. We have how many attributes? 1, 2, 3. We have 3 attributes. This means that the degree of our relation is 3. We have also some tuples or records. We can count them from the first to the last. We have the first record, second record, and the third record. So cardinality will be equal to 3. So we have tuples or rows where cardinality refers to the number of rows. Here is 3. And also we have columns or attributes. Here we have first column, second column, and here we have third column. So the total number of columns or attributes, that is what we call the degree of a relation or a table. On this table, we have also what we call key relation. This one is a primary key. So the primary key is attribute or a group of attributes which uniquely identify each record. You see that, for example, the primary key of our table is called the customer ID. So here, the value of customer ID on the first row is 1, the value of customer ID on the second row is 2, and the value of customer ID on the third row is 3. It means that this value should not be duplicated. They are unique. They are used to identify each row or each table in this relation. So we call them the primary key. Here we have also domain. You see that here all cells have the values. So we can say that domain, the attribute which is called the customer name, cannot be null. So null value in the concept of database management system does not mean 0. Null value means empty value. So here the value here is Google. It is not a null value. Here the value is Amazon. This is not a null value. And here the value is Apple, which is not a null value. So domain of attribute called customer name consists of characters, words, or names where no cell is allowed to be given a null value. Now let us see what we call relational constraints in database management system. So we have said that each table or each relation has a finite number of attributes or columns. So each attribute must have its specific name. So, and also, depending on the data type or the kind of data to be stored within that attributes, we should create some rules on each column to limit some values. So those rules will be called constraints. So constraints are the rules enforced on data columns of table. What is the role of constraints? Constraints should be used to limit the type of data that can go into a table. For example, if a specific attribute has given character data type, it cannot be given integer numbers. We will insert only the letters. So we have three main categories of relational constraints in a relational database management system, namely domain constraint, key constraint, and referential integrity constraint. We are going to discuss about each one later. So, domain constraint. Domain constraint defines the domain or the set of values for attribute. And the domain constraint specifies that a value taken by attribute must be the atomic value from its domain. So we already know what domain is. A domain is a set of values which are allowed to be assigned to an attribute, a specific attribute. So once there is a condition on that attribute, only the values satisfying the condition will be assigned to that attribute. So the values within the values of an attribute whose constraints is a domain constraint must be atomic, means they must be indivisible. They are smallest and indivisible units. This means that this attribute is not a composite attribute, and also this attribute is not a multivalued attribute. So it is able to accept a single value which lies in the range obeying the condition which has been created on this attribute. Most of the time we use a check constraint. We will discuss about the types of constraints later. So here we have an example of a relation where there is a domain constraint on one of its attributes. So we have a relation which is called student relation or student table. We have student ID as the first attribute. We have name as the second attribute, and here we have age as the third attribute. So you see that the data type of this attribute, age, will be integer numbers. But for the student whose name is called Raul, you see that age of Raul, the value of ages for Raul is A. A is not an integer number. So you see that this constraint has been violated. So A must not be inserted in this location because it is not an integer number. So we can say that the domain for attribute called the age will be the set of integer numbers. So this one is a character, is not an integer number. So here the value A is not allowed, since integer values can be taken by the age attribute. So that is what we call the domain. A does not belong in the set of integer numbers. It cannot be inserted within this location. The following relational constraints are key constraints. Key constraints specifies that in any relation, all values of primary key must be unique. Remember that a primary key is an attribute or a column or a field which uniquely identifies each record of a relation. This means that the values of the primary key are always not null, and also the primary key cannot accept duplicated value, or we can say that the primary key values are always unique. The values of primary key must not be null. Here we have an example we have a relation which is called the student, where we have three attributes. We have student ID attribute, we have name attribute, and the age attribute. Each attribute has its own values. But here, this underlined attribute means that it is the primary key. So it has to identify each row of this relation. So as I have told you, the values of primary key are always different. So the primary key cannot accept duplicated or redundant values. So here on the first record, the value of primary key is S001, and here the value is S001. So this means that student ID, even if it has been underlined, it is not a primary key, because here we have two values. We have one value which has been repeated in other record. So the values of the primary key must be different, must be unique, because they are used to identify each record from other records. So we concluded that student ID here is not a primary key. So in this relation does not satisfy the key constraint, as here are the values of primary, as here all the values of primary key are not unique. So student ID is not the primary key. The following constraints are referential integrity constraints. This constraint is enforced when a foreign key references to primary key of a relation. So in a relational database management system, we can create a relationship between two or more relations. To create a relationship, we must have first of all the primary key, which is an attribute that uniquely identifies each record from the others, and in other relation we have what we call a foreign key. So a foreign key is an attribute which has been used as the primary key in other relation. So differential integrity constraints specifies that all values taken by the foreign key must either be available in the relation of the primary key or be null. This means that the values of foreign key should be duplicated, or the values of the foreign key should be null. Null, as I have told you, does not mean zero. Null means empty, unknown value for that attribute. So here we have example of two relations. We have student relation and department relation. Here student references the relation department. This means that the foreign key will be in the department, the foreign key will be in student relation, because student relation references department relation. It means that the foreign key is an attribute of student relation which has been used as the primary key in a department relation. So do you see that here the primary key of a student relation is student ID, and here the primary key of department relation is department number, and you see that this department number has been used as the attribute which is not a key in student relation. So we say that student relation is a referencing relation because it is one whose the foreign key is one of its attributes. Whenever department relation is a referenced relation because the primary key of department relation has been used as the foreign key in other relation. So we can consider two tables where the first table is called the customer and the second table is called sales. So customer table has customer ID as the primary key. And the sales table has sales number as the primary key. But among the attributes of sales table, there is an attribute which is called the customer ID. And remember that this customer ID has been used as the primary key in a customer. So you see that the two tables, there is a relationship between customer relational customer table and sales table because we have the primary key and the foreign key. You see that the values of the foreign key must be the values which exist into customer ID, which is the primary key of customer table. And as I have told you, the foreign key should accept null values, and also the foreign key should be duplicated. So this means that we have one which has been duplicated. We have two ones in two distinct column rows, and here we have two. One exists within the primary key, which is the customer ID, and also 2 is a value from the primary key, and here 3 also is the value from the primary key. Sorry, let me correct myself. The characteristics of foreign key are the following. The values of foreign key are always different from null values. It means that the foreign key cannot accept a null value. This means that we cannot have another record whose value does not exist among the values of this primary key. And also, the foreign key should have repeated values. Thank you for watching my video. Don't forget to subscribe on my YouTube channel so that you should get new videos. Thank you very much. See you next time.